Alright guys, so that's what we're doing today. We're doing the average rate of change. It's basically just a fancy word for slope. So that's what we're doing today. We're doing slope. Let's go ahead and get cracking. So we kind of mentioned this already, but when it comes to straight lines, they always have the same slope. Like this one is over 1 up 2, right? Or if I were to go at this point here, it's still over 1 up 2. It doesn't really matter what 2 points you pick. I could even pick 2 points that are really far apart, like I could go over, it's like, I don't know, let's see. I went over 3 and up 1, 2, 3, 4, 5, 6. But 3 over 6 is the same thing as 2 over 1, right? So the slope is the same no matter what 2 points you pick, right? But when it comes to a curved line, that's not the case. Like from this point to this point, the slope is 1. Or from this point to this point, the slope is rise 3, run 1. So that's a different slope, right? So when it comes to curved functions in pre-calculus, what we're going to do is we're going to find what's known as the average slope or the average rate of change. So the way you do that is basically you're just going to pick 2 points. You're going to imagine like a straight line between them, find the slope of that straight line. And that would be the average slope, okay? I think a good way to look at it would be, let's say you guys were driving to Vegas, right? And that's about, what, 400 miles away or something like that. And it takes you about, let's say it takes you, no, it's too many miles. How many miles is Vegas? 300? Okay, thank you. So let's say it's 300. And it takes you about 4 hours to get there. So what you do is you take the miles and you divide it by the number of hours it took you to get. How long did I say it takes you to get there? 4 hours? So how many times is 4 going to 300? And what does that tell us? 75. Yeah, basically your speed, right? 75 miles an hour. But really, does that mean that you were going 75 miles out the whole time? No, that's just your average speed. Because really, at some points you probably were going faster. Other points you're probably going slower. You probably stopped and got something to eat on the way, right? So it doesn't mean you're literally traveling 75 miles an hour the whole time. It just means that on average that was your speed. Well, we don't have an exact, like, what is the slope of this function? Well, there's an infinite number of slopes on this function, but what you can do is you can find the average slope. And slope is a rate of change, so we call it the average rate of change. Okay? So, I don't know if this formula probably doesn't look familiar, but I'll try to make it look a little bit more familiar. It's just y2 minus y1 over x2 minus x1, but it's written in function notation. So if you have a function, the average rate of change of that function, also known as the average slope, on the interval from a to b, so that's kind of important because it depends on what interval you pick. You know, if you're picking this part of the function, you'll have one slope. If you pick a different part, you'll have a different slope. So we have to specify a particular interval that we're looking at. But on the interval from a to b, the slope would be whatever the y value is at b minus whatever the y value is at a over the difference between b and a, which is just y2 minus y1 over x2 minus x1. This slope formula, that's all it is. So don't let it look too fancy. And just like we learned back in our first unit, if it's positive, that means it's sloping upwards. Okay? So you can imagine a line going upwards. That doesn't mean it's a straight line, right? It just means it's curving upwards, possibly. If it's negative, that means it's decreasing. So we'd expect it to be going down from left to right. And then finally, if it's 0, then it looks constant, straight across. All right, so let's go ahead and do one of these here. It says, find the average rate of change of the function on the indicated interval and determine if it is increasing, decreasing, or constant. So here's my function, right? And here is my interval. We're going from 1 to 8. And that 1 to 8, are those x numbers or y numbers, you guys? Those are x's. You can tell because the x right in the middle there. So we're going from x equals 1, right, to x equals 8 for number 1, right? Okay, so let's do it. We want to find the average rate of change. That's just a fancy word for what? Slope. So we're going to do y2 minus y1 over x2 minus x1, right? So what should we call this one? You could call it x2 or x1. I'm going to call it 1 just because it comes first, but it doesn't matter. You would get the same answer. And I'm going to call this one x2. So if this is x1, what's this one? And this one? y2. So we just get to plug it in and that's it. So 65 is y2 minus y1, which is 8, over x2, which is 8, minus x1, which is 1. 65 minus 8. Oh, did I do it wrong? So this one's supposed to be what? 2, my bad. So y2 is, or y1, I mean, is 2, right? My bad. Thank you. Good catch. All right, I owe you one. All right, 65 minus 2 is 63. 8 minus 1 is 7. So my average rate of change is 9. That means that for this function, as I went from x equals 1 to x equals 8, the function went up 9 spaces. That's what that means. Now, it could have curved to get there, but the average rate of change was over 1 up 9 from 1 to 8. All right, let's go ahead and take a look at number 2 here. Same thing.
So you got 9 for the slope, right?
I'll get you there, my left. Huh?
You got 9 for the slope. Right?
That's correct.
So how did you figure it out by just looking at 9 that it's one up, one down?
Say your question again?
How do you know if it's like increasing, decreasing, or constant?
Oh, that's a good question. Thank you for asking that. I don't think I answered that, so I'm glad you asked. Let me get down Melanie's point here. All right, so I didn't answer this question, guys. So let's answer it. Is that increasing, decreasing, or constant? Why is it increasing? It's positive. So when your slope is positive, that means you're going up. So thank you for asking that, Dana. I think I'll give you a point too. On the last slide, we said that if the slope is 0, it's constant. Now, here's the thing. We're talking about average rates of change, which means that the average rate of change could be 0. So let me show you something interesting. If you had a parabola, let's say, and you're going from here to here, that's going to look constant. It's going to look like a 0 slope, right? But was it really? I mean, really, no. Whatever it was, it decreased and then it increased. So there was definitely some changes happening as it went from one point to another. But it looks like in the end, nothing happened because you ended up right back where you were at the same height. So this is only an average rate of change. So let's go ahead and take a look at number 2 here. So for number 2, we're going to use a different set of x and y values. We're using the x values of -3 and 5.
So we don't have to look at the sign.
There's no 5 on my x.
Yeah, I was like,
Let's change it to a 6. Sorry about that. So we'll go with this one. What was your question there, Zana?
Like, it has those greater than a less than sign, right?
Uh-huh.
When you look at those, you just take the base numbers.
Okay. So Xana wants to know why are these greater than or less than symbols there? So what we're doing is we're finding like average rates of change, right? So let's go back to our parabola example. So right now we're going from x equals -3 to 6. So let's say -3 is like here. And let's say 6 is here. And we're finding the average rate of change from the point on the left to the point on the right. So what's up with this less than and greater than? What that means is that we want to find the average rate of change for the function for all the x values between -3 and 6. So we're looking at an interval. When you talk about intervals, we talk about from least to greatest. So that's why it's there. But when we actually do the problem, do we actually use them for anything? No. It just means we're looking at a particular range. All right. I don't know if this is a parabola, by the way. I'm just kind of keep using parabolas as examples. They're nice examples. Well, let's go ahead and do this. So what am I going to call this guy here? Okay. And this one? And that one's going to be y and y. All right. So let's plug it in. 37 minus 10 over 6 minus a -3. And 27 over 9, which is 3. And is that increasing, decreasing, or constant? It's increasing again because it's positive. Okay, so that's average rate of change. That's basically just slope, right? Let's go ahead and have you guys practice a little bit using tables. I'll give you a second there. So there's our answers there. Any questions about anything before we proceed? Okay, let's roll on to the next story here. So we looked at how you can find slope from a table. Now we're going to look at how you can find slope if you just have an equation. Okay, so did I print this one for you? No? Or I did? Okay. All right, so let's do it. Is it on the back? Oh, okay, got that. So here's the thing. Huh? Of course. So if you need to use it, if you want to calculate slope, what do you need? You need 2 y's, right? And you need 2 x's. What do I have in this problem? I've got 2 x's, but I need 2 y's. Now in the table, we could just look at the table to find those y values, right? How can I get the y's here? Just plug them in, okay? So that's the difference, is that when you have an equation, you have to find your y values by plugging in the x's to get the y's. So let's go ahead and do that. So what am I going to call x1 here, you guys? Let's start with 0. So let's find the y value that goes with 0. You'll find that by plugging it in. Oops. Minus 9. So f of 0 is equal to -9. So that's going to be your y2 then, is -9. So when x equals 0, y equals -9. I said y2, that's actually going to be y1, my bad. When x1 is 0, y1 is -9. Let's find x. Let's find y2 now. What is x2? 3. F of 3 is +9, it looks like, which is our y2 now, right? Yes, I do know that. I know that very well. And it's your job to learn to know that. That's correct, Sam. Yeah, you know how teachers are. We like to do the easy problems in class and put all the hard ones on the homework. Well, it's not us doing it. We'll give you guys the hard work to do. I'm just joking. That's really not our intention. It does kind of turn out that way sometimes. Here we go. So I now have enough information to find my average rate of change, which is just a fancy word for slope. So y2 minus y1 over x2 minus x1. So I end up with 18 over 3, which is 6. And that would be increasing once again. So that's how you can find your slope. Yes, John?
Can you just tell 0 and 3 if you're getting the on your
Whether it's increasing or not? I don't think so. Let me show you why. Unless you want to go through the trouble of graphing this, it's kind of hard to tell. Because here's x equals 0, here's x equals 3, right? Now, don't you agree that my parabola could be doing this on that interval? Or it could be doing this on that interval. Or maybe it could be doing this on the interval. So we really don't know as we go from 0 to 3 whether this thing's going down or up. So when we're looking at slope, the x's always go from smallest to largest. The question is, what are the y's doing? So if we're going from negative, as x goes from 0 to 3, my y value goes from a smaller number to a bigger. So that way you can tell by looking at the y values. But the problem is that part of the thing I want you to do also is actually find the slope, so you might as well just calculate it. But you're right. You can tell just by looking at the y values if it's increasing or decreasing, but not by looking at the x values. All right, so that's how you can find slope from an equation. Shall I delete? All right. And you guys get to practice, of course. So there's that. Any questions? Yep. All right. Last thing we're going to do today. Save the best for last. Sketch a function that is all this stuff. All right. So I'm going to show you guys how to do this. The first thing you want to do is let's make a graph. And on our graph, we want to go from our smallest x value to our largest x value. Okay? Huh? Huh? You're right. You guys notice those are brackets? Remember brackets are intervals? We talked about this on a day of your test, remember? Like this. Is the same thing as that. You should come back over here. Okay, so this is an interval. These are x values. And you want to know something that's really confusing, although it doesn't really matter for this lesson today. This can be an interval also. The only way you know is by reading the question. If it calls it an interval, then it's an interval. You guys remember the brackets means it can be equal to. The parentheses means it can't be equal to. So you have to read your question there and know if it's an interval. But in this case, these are intervals. So I want you guys to know these are all x values. Okay? So we're going from an x value of -4 all the way up to 5. So let's do that. -4, +5. Okay? So what's the first x value they gave me? What's the next x value? 0. So let's put that on there. What's after 0? 2. And then after that, 5. So what we're doing is we're looking at 3 different intervals here. We're looking at the interval from -4 to 0. We're looking at the interval from 0 to 2. We talked about that. It is. Just take my word for it. And then you might have been on your phone, sir. We just had like about a 2-minute conversation about that. All right. So, well, I mean, I just talked about it for like a solid 2 minutes. All right, so from 2 to 5 is the other interval. So, we have 3 intervals, orange, green, and yellow. You guys good? What are you laughing at? Just trust me. All right, so what's happening on the orange interval, the interval from -4 to 0? It's increasing. So now it doesn't matter where you start because it says sketch a function, not the function. It's not like this is the answer. We want to just make a graph that fits this criteria. So I want to sketch a function that's increasing from -4 to 0. So it doesn't matter where you start. So let's all just put our pen somewhere, right? But it's got to be at underneath -4 or above it. It doesn't really matter. Let's put our pen at -4. And what's it say we're doing from 0 to or -4 to 0? We're increasing. So as I go from -4 to 0, I'm increasing. Okay? Now let's continue. The next one, what's happening from 0 to 2? So as I go from 0 to 2, we are decreasing. Oops, I went too far, I think. We got to stop at 2. It doesn't matter how far down you go. But the point is, once you get to x equals 2, you stop. All right? What happens on the interval from 2 to 5? It's constant. What does constant look like? Straight across. That's it. So as we go from -4 to 0, we go up. And as we go from 0 to 2, we go down. And from there, we go over. Okay? So the first thing you want to do is set up your graph, right? And then from there, you guys can draw it out. You guys listo? Listos? What's up? We good? All right. Good to hear. Here's one for you guys. Draw me a graph that is constant on the interval from -5 to -3, increasing on the interval from -3 to 1, and then decreasing on the interval from 1 to 4. The interval here is from -5 to -3, so my graph's going to be doing one thing on that interval, and then for the next interval from -3 to 1, it's going to be doing another thing, and then from 1 to 4, it's going to be doing still another thing. So let's see what those things are. So from -5 to 3, it's constant. So that means that from here to here, I should have a straight line. I saw some of you guys put your straight line right on the line. I saw some of you guys put your straight line right below the line. But it doesn't matter. The point is the slope is the same all the way across. Okay? Then, after that, you should have, is that what you're going to ask, Anna? Okay. So on the interval from -3 to 1, the green interval, it should be increasing. So we're going to be going up. And then on the, oh yes, I didn't go far enough, did I? Let me go a little further. Because you do want to go all the way to 1, right? And then decreasing on the interval from 1 to 4. Now that's what most of your guys' graphs look like, and it's fine. But technically, it could have been curved, right? Who says it has to be sharp, right? The point is it going up. You get full credit for having it with straight lines. That's fine. Some of you guys had this. Some of you guys had this. But it doesn't matter. You had the right shape, right? From -3 to -5 to 3, it was constant. From -3 to 1, it went up. And then from 1 to 4, it went down. That's it. That's all that's really required, and that's slope. We're going to build on this concept next time. So this is kind of like a nice little review. We're going to build on this. We're going to add something else to it next time called concavity. But I am going to stop our lesson here for the day. And we're good.